Okay, right, all of you? So this is very simple questions. These questions belongs to the operational amplifier. These questions are belongs to operational amplifiers. In these operational amplifiers, first question. In an ideal operational amplifier, the output impedance is. An ideal operational amplifier, what should be the output impedance? The output impedance of an ideal operational amplifier is 0. The output impedance of an ideal operational amplifier is 0. And coming to the next question. This is a very important question. The input resistance of an ideal operational amplifier is infinity. The input resistance of an ideal operational amplifier is infinity. Next. Generally, the common mode rejection ratio of an ideal operational amplifier, CMRR is equal to differential gain by common mode gain. Differential gain by common mode gain. For an ideal operational amplifier, the common mode gain should be 0 and differential gain should be infinity. Answer is infinity. If it is a practical operational amplifier, the CMRR may be 100 decibels or 120 decibels in that order for practical operational amplifier. So CMRR is infinity. Next. Just now we discussed that point, even I don't know this question will come, but again this question has came. What is this question? The ideal operational amplifier, practical operational amplifier CMRR is 120 decibels. Just now I told you na, for the practical operational amplifier, the CMRR is how much? 120 decibels. Practical. This one. Next. Basically, what is an operational amplifier? Operational amplifier is a high gain direct coupled amplifier. High gain direct coupled amplifier. This is a very important question. High gain direct coupled amplifier. Next. In practical operational amplifier, the voltage gain should be very large. The voltage gain should be very large. Voltage gain should be very large. An ideal operational amplifier, the voltage gain is operational amplifier minus infinity. For inverting amplifier, it is minus infinity. Minus infinity. Yeah. Right, Amma. Very simple questions, but next. The closed loop gain of an inverting operational amplifier is. Inverting operational amplifier gain is what? So this is your op-amp. This is a closed loop. What is this one? This is RF. This is R1. What is this one? Minus RF by R1. Minus RF by R1. So gain of the amplifier is minus RF by R1. 1 plus RF by R1 is answer for what? 1 plus RF by R1 is for what? Non-inverting operational amplifier. 1 plus RF by R1 is for non-inverting amplifier. Minus RF by R1 is for inverting amplifier. The Operational amplifier circuit shown. This input is fed back to this one output. So what happened? You are giving input is here. Same you are getting the output voltage here. It's a voltage follower. This circuit is a voltage follower circuit. What circuit? Voltage follower circuit. This type of models they may ask you. Which of the following is not a characteristics of an ideal operational amplifier? Generally bandwidth is infinity, CMRR is infinity, voltage gain is minus infinity, input resistance is infinity, input resistance is not a zero. So, is not a characteristics means Ri should be infinity, Ri is not zero. Ri is not zero. Next. In the given op-amp, the gain is minus Rf by R1 minus 10 by 1 is equal to minus 10. Answer is minus 10. Answer is minus 10. Good evening, ma. Good evening. Next. The operational amplifier slew rate is volts per microseconds. Volts per microseconds. Units for slew rate is volts per microseconds. Units for slew rate is volts per microseconds. Next, the following circuit is acts like a, whenever if the capacitor is here, resistor is here, it acts like a differentiator. It acts like a differentiator. Suppose if the capacitor is here and resistor is here, if it is interchanging, that acts like a integrator. That acts like a integrator. Okay, ma? Right? Next. What about this? The following circuit acts as a, when R is equal to R, both the values are same. Both the values are same means gain is minus 1. Gain is minus 1 means what? Inverter. It acts like a inverter. It acts like a inverter. The operational amplifier circuit shown in figure. Whenever if the diode is placed at the feedback path, it acts like a logarithmic amplifier. This one acts like a logarithmic amplifier. If the diode is placed at the top of the operational amplifier as a feedback amplifier, that acts like a logarithmic amplifier. Suppose if the diode comes here for this place, that becomes like a anti-logarithmic amplifier. If the diode comes here, it becomes like a anti-logarithmic amplifier. Next. An inverting op-amp has Rf is equal to 100 kilo ohms. R1 is equal to 20 kilo ohms. The gain is minus Rf by R1. Minus Rf by R1. How much it is? Minus 100 by 20. Minus 100 by 20. Minus 5 is the answer. Because of inverting op-amp. Because of inverting op-amp. Next. The non-inverting op-amp has Rf is equal to 100 kilo ohms, R1 is equal to 20 kilo ohms. Non-inverting op-amp, 1 plus Rf by R1. 1 plus Rf by R1. 1 plus Rf is how much? 100. R1 is how much? 20. This is 6. This becomes like a 6. Because of inverting, non-inverting and inverting. Next. So you have to go through study about the 741 IC. You have to go through the 741 IC. So in the 741 IC, the pin 2 is acting like a inverting input. Pin 2 is acting like a inverting input. Pin 2 as a inverting input, pin 3 as a non-inverting input. Pin 3 as a non-inverting input. Pin 3 as a non-inverting input. You go through that, what are the pins are available. Pin 6. So go through that IC, sometimes they may ask you. Output terminal. This is output. Pin 6 is a output. All are related to pin 6 only. The output resistance of a IC, usually what should be the output resistance for an operational amplifier? Output resistance should be very low. So this is 75 ohms. The output resistance should be 75 like this. Because the output resistance of operational amplifier should be less. So this is having 100 kilo ohms, 2 mega ohms, 1 mega ohm. Large values are there. Small value is possible for 75 ohms. That's why output resistance of IC is 75 ohms. Next. RF is equal to 0 and R1. If RF is equal to 0 and R1, the inverting operational amplifier converted into RF is equal to 0. What is RF is equal to 0? RF is equal to 0 means you will have the feedback element is to be 0 like this. It is like a voltage follower, na? This is like a voltage follower. This circuit is like a voltage follower. Next, if RF is equal to R1, the inverting amplifier converted into RF is equal to R1 means minus 1 you are getting. Gain of the amplifier is minus 1. Minus 1 means what? You are given input, same output you are getting with sign. Sign changer. Output is same as the input, but here sign is changer. That's why sign changer. So, next question, ideal operational amplifier has bandwidth of infinity. Bandwidth of infinity. So, these are all the questions related to operational amplifier. So, today we will close our session. Already the time is 8 o'clock. So many topics we discussed. If possible, I will discuss about the amplifiers tomorrow. And I will intimate in WhatsApp what is the subject for tomorrow. Probably I will take the subject as a AC fundamental. Anyhow, I will give the confirmation. Okay, ma? Clear all of you? Right, Chana. Bye all of you, please. Afternoon only, after 3 o'clock. Most probably, after 3 o'clock, I will take the class. Morning you try to prepare, afternoon I will take. As usual, you go for your preparation. I think today one subject you revised. Most at least 50% of the subject you revised about the basic electronics. Okay, ma. Bye. Right, ma. Sure. Bye all of you.